Hello folks, so in this video, let's pretend that we want to find the area of some triangle. Okay, so I want to find the area of this triangle, that I'm about to draw. Okay, and so let's do that by drawing a triangle, something like that. It is not a right triangle, quite clearly. I tried to make it clearly not a right triangle. That angle up top, maybe it's close to 90, but I think it's pretty clear that it is an obtuse angle. Well, if I wanted to find the area of a triangle, I know from geometry that the area is equal to 1/2 the product of the base and the height. So let's do that. It equals 1/2 base times height. Nothing too crazy there. Okay, so let's generalize this by putting some letters into this triangle. Okay, so I'm going to label the side lengths of this triangle. Oops, sorry about that. I'm going to call it A. Sorry about that, I have my ink to shape turned on. A over there, B down here, and then C. So big A, big B, big C are the side lengths. Okay, so, well, since B is already across the bottom, might as well call B the base. We'll use this for B, and then we'll use H for the height here. Okay, and the height, well, I don't see a height drawn in or an altitude drawn in, so I'll draw one in now by doing this. And it must be perpendicular against this side. And that's going to be H. Alright, hang on a second. Now that I've drawn in that altitude, I actually have some right triangles, and we know all about right triangles. So, assuming that I knew the angles, let's throw in some angles here. I'll call the angle down here A, so that's opposite. That's the angle that is opposite the length of the side of length A. Excuse me. This angle over here will be C, and this angle up top total will be B. Although that's not really relevant right now. Little b. Well, the height, if we use a little trig, well, I can look here at this triangle on the left side in green that I'm drawing. If I look at it using that side, I can figure out what H is. I can say that 1/2 B, and the height, I'll do this in green, is equal to just, well, A times sine of C, sine of little c. And that's H right there. Take a second and convince yourself that is the case if you're not quite clear yet. But there's no reason I have to look at that from the perspective of the left triangle. I could also look at it on the right side. And I'll use purple for this one. Like so. If I look at that triangle, or from that triangle, I have 1/2 B, that's still 1/2 times the base, but the height now, well, the height now would be what? I think it would be big C times sine of little a. If that's the case, well, check this out. So by the way, the point of this video is not actually to find the area of the triangle. It's actually to show you something else. It turns out that, well, I could divide left and right by 1/2 B. These are just, again, two different ways of looking at the area of this triangle. And it turns out now, if I clean up this equation, we get something that's kind of pretty in its simplicity. I'll end up with, and I'll finish up in black here, I have A sine of C, little c, is equal to big C sine of A, and if I divide the left and right by A and C, divide by AC, we see something really interesting. We end up getting this. I'll bring it over to the left side, or to the right here. I have sine of C over the side of length C is equal to sine of A divided by length A. So it turns out this ratio is actually always going to be true. And we can see that we just proved it here because I didn't use any specific numbers. I just called it A, B, and C, whatever they are. You might realize, well, what about B? Well, there's no particular reason we had to use this setup. If I had drawn the triangle the other way, let me try to do that once more here. I'll copy it down here. Do it something like that. And I'll keep everything exactly the same. I believe this was A, B was down here. B, little a, oh, sorry, forgot side length C, like that. Let's pretend I wanted to use B at, sorry. Let's pretend I want to use side length A as the base now. We'll use A as the base. Okay, so by the way, the area of this triangle should be the exact same as the area above as well. Well, the altitude that I would draw then would have to come from here, and so it's going to be a little bit harder to draw. I would have to extend this side to get that altitude, but that's okay. Like so. Okay, so kind of going to have to turn your head here. But this would say that the area of this triangle is equal to 1/2. The base now is A, oops, sorry, not B, is A, times the height. Now, the height is actually, so this is going to be a little bit hard to draw here. Big C was this side length. H would be this right here. And so we can use either this really skinny triangle with side length C, or we could use the really the bigger triangle with side length B. But if that was the case, well, we got to do a little bit of finagling here, because it turns out, oops, let me highlight this in yellow here. If I use this triangle right there, well, then I have to figure out what this green angle is first. I have to figure out what that angle is. Sorry, I momentarily confused myself. Also, I realized that I was using A twice, so the area is equal to 1/2 A times H. So once again, if I want to use this skinny yellow triangle, I have to figure out what this tiny little angle is there. We'll call it theta for now. That angle right there, call it theta. Well, remember that purple ray that I drew, magenta ray, is just a continuation of side length A. And so that forms a linear pair, that green angle theta and the little angle little b, those are supplementary angles. And so I know that theta is actually equal to 180 degrees minus b, or pi radians if you want to say. Okay, but now that I know that, I can say that the area is equal to, well, that would be, let's see, 1/2 A, again, that's the base, is A now, times, well, just like before, it's going to be C. To figure out what H is, we need to multiply by the hypotenuse of this triangle, which is C, times sine of theta, which is 180 minus B, 180 degrees minus B. Now, if I look at it from the lens of the giant triangle, which I'll highlight here in blue here, or cyan, this color, well, it's a little bit, this one's a little bit easier to see, because we can just say now that, and I'll use this for blue, this is just going to be 1/2 A, and again, 1/2 the base. Sorry, let me scooch that over. Times B sine of little c. And hopefully you might have to do a little mental gymnastics, flip your paper around sideways, and maybe see that. But once we have this, we can see, actually, well, there's this kind of big mess here with the sine of 180 minus b. But check this out. If I draw, let's pretend B is some obtuse angle, right? So I'll kind of draw roughly where B is. This is B. This would be 180 minus B. This would be theta from above, right? Okay, notice that these two angles have the exact same sine value, because this point right here, the y coordinate on the, if I was on the unit circle, the y coordinate would equal, sorry about that, is equal to sine of B. But it's also equal to sine of theta, which is also sine of 180 degrees minus B. And so any angle has actually the same sine value as its supplement, little teacher there. So we can actually say that this is just equal to sine of B. Okay. So if I clean this up now, we can see 1/2 A times, let's see, sorry, my brain froze. AC sine of B is equal to 1/2 AB sine of little c. We can do what we did before. We can divide both sides by 1/2 AB, 1/2 A. So we'll get C times sine of B is equal to B times sine of C. We'll divide both sides by B and C. Oops, that's a little messy. And we'll see some stuff cancel. Left with sine of B over big B is equal to sine of C. Oops. Sine of C over big C. Now if we go back to where we started, we already said that sine of C over C is equal to sine of A over A. And so we can just throw that in here as well and say that sine of A over A is also equal to that. This is pretty cool, in my opinion, and something that I think deserves its own name. And it has its own name. This thing is called the law of sines. Okay. And it all came about just because you could look at the area of a triangle in a number of ways. You could look at it this way, you could rotate it and look at it as with A being the base, B being the base, or C being the base. As long as we know a little bit of trig, we can actually kind of solve this without much problems. Okay. I'm going to add into the playlist a couple videos that I think will be helpful for now finding out any information that you are missing from any given triangle. Okay? Thanks for watching.